Hello students, in this video we are going to learn about formation of N-type and P-type semiconductors. These semiconductors are prepared by the process called doping, which we have already learnt in the previous video for introduction of semiconductor devices. Doping is a deliberate process of adding impurities in order to increase the conductivity of intrinsic semiconductor. So, we begin with N-type semiconductor, which is obtained by adding a pentavalent impurity like arsenic, phosphorus and antimony etc. from the group 5 elements in the periodic table with a tetravalent silicon or germanium atom. You can see the diagram which is given where the impurity is added, one of these pentavalent elements that is added, and which forms, because it has 5 valence electrons and all these 4 electrons out of 5, that forms the covalent bond with the adjacent, the neighboring silicon or germanium atoms, but only one is left free, and that is the unbonded free electron donated by a pentavalent atom. Hence, these semiconductors have free electrons contributed by the impurity atom as well as by the thermal process. By the thermal process, there is always jumping of electron from the valence band to the conduction band, and hence there is always contribution of electron due to the thermal process as well as by adding such pentavalent element with these semiconductors. Therefore, here there is one free electron which is available, and hence the number density of electron, by adding this pentavalent impurity, the number density of electron will be more than the number density of holes. You can see Ne, that represents number density of electron. It is always much greater than the number density of holes. The holes which are purely created by the jumping of electrons from one energy level to another energy level, that is due to the vacancy created by the electrons. But here in this case the electron number is more. Why? Because the electron contribution is due to thermal agitation as well as due to the adding of pentavalent element with this silicon or germanium atom. Therefore, we understand in N-type semiconductor, electrons are the majority charge carriers because the number density is more, and the holes, they are the minority charge carriers. In our further discussions, we will go with majority charge carriers and minority charge carriers. In the similar way, when we look at this P-type semiconductors, they are also obtained by doping a tetravalent semiconductor like silicon or germanium with a trivalent impurity like boron, aluminum, gallium, etc. So here the impure atom, it uses 3 electrons on 3 sides here to form the covalent bond with the neighboring atoms like a silicon on neighboring side, and having only one incomplete covalent bond because there is a deficient electron. We know that a trivalent element, it has 3 valence electrons, and hence all the 3 sides are filled with the neighboring atom, but only one side is incomplete because deficient electron is there and leaving the vacancy there. This incomplete is filled by the electron which comes from the adjacent silicon covalent bond that slides into vacant bond, leaving a hole on its place, because when this electron, it jumps to fill this place, it leaves always a vacancy, and that vacancy always creates a hole, and that hole will be called as a positive charge carrier. As we know already, holes behave as a positive charge carriers, and this hole is available for conduction. These holes are created by the acceptor atoms because the impurities here are called as acceptors. Therefore, the number of holes are contributed by the acceptor atoms and also by the thermal generation. Hence, the number density of holes is greater than that of number density of electrons in this P-type semiconductor when we are adding the trivalent impurities with intrinsic type semiconductors, and hence we have NH is much greater than Ne. Therefore, such semiconductors which are prepared paired by adding a trivalent acceptor atoms are called here as a p-type semiconductors. Here we have to remember the holes behave as a majority charge carrier since the number density is more, and the electrons are called as a minority charge carriers in p-type semiconductor. I hope you understood the formation of p-type and n-type semiconductors very well. Thank you for watching.